So, good morning. This is the last lecture. So this is the last lecture on the numericals we have been conducting on the impact of jet on moving plates. Okay. So we'll solve the last problem. A jet of water having a velocity of 40 meter per second strikes a curved vane which is moving with a velocity of 20 meter per second. So the velocity of the jet is 40 meter per second, capital V, and the velocity of plate is u, 20 meter per second. The jet makes an angle of 30° with the direction of motion of vane at inlet and leaves at an angle of 90° to the direction of motion of vane at the outlet. Okay. Draw the inlet and outlet velocity triangle at inlet and outlet and determine the vane angles at inlet and outlet so that the water enters and leaves the vane without shock. Now, this is an example of impact of jet on moving curved plate when the jet strikes tangentially at one end. Okay. In this problem, we are going to draw the inlet velocity and the outlet velocity triangle. First, we will see what are the given points. Okay. What is given in the problem? This is the velocity of the jet at the inlet, which is V1. It is 40 meter per second. The curved vane is traveling with a velocity of 20 meter per second. U is 20 meter per second. Okay. Next, angle made by the jet at inlet alpha is 30 degrees. Okay. Angle made by the jet at inlet, it is 30 degree. What is alpha? We'll see in the diagram. Angle made by the jet at the outlet is 90 degree. Okay. So the angle at the outlet, angle made by jet beta, will be 180° minus 90, which will be 90°. We'll study all this in the diagram in the next slide. Now here, velocity of the plate is u. Velocity of the plate at inlet is u1. Velocity of the plate at outlet is u2. And overall velocity of the plate is u, which will all be same, which will be equal to 20 meter per second. Okay. Now we will see how the jet is acting on a moving curved plate. Okay. This is a moving curved plate. The jet strikes the plate tangentially. Okay. Now the direction of that jet is AB. AB represents the absolute velocity of the jet in direction and magnitude. Now that absolute velocity is given as V1. Okay. Now the value of V1, it is given here, it is 40 meter per second. Okay. Now this velocity V1 or AB makes an angle alpha with the horizontal AD. Okay. Now angle of alpha is also given. What is alpha? It is the angle made by the jet with the direction of motion of vane. Okay. That is alpha and it is 30 degree. Okay. This is the direction of jet and the motion of the vane is in the x direction. That is, this direction is the motion of vane and this is the direction of jet. So the angle between the two is alpha, which is in this problem it is given as 30 degree. Okay. Now AC will consider it as U1. Okay. And we have seen U1 is equal to U2 is equal to U, which is 20 meter per second. Now connecting, as the jet strikes the plate with a relative velocity Vr1, CB represents Vr1. Okay. BD represents Vf1, that is velocity of flow, and AD represents the velocity of whirl at the inlet. We have discussed this in lecture number 9 itself. Okay, when we were drawing inlet triangle and outlet velocity triangle. Okay. Now this angle is theta. Okay. So we have been told to determine the vane angles at inlet and outlet. So theta is the vane angle at the inlet. So one quantity that we have to find out, one property which we have to find out is the theta. Okay, now if you go at the outlet, okay, what does the question say? It the jet leaves at an angle of 90 degree to the direction of motion of vane at the outlet. Okay, so this is the motion of vane in the x direction, and the jet leaves at 90 degree to the, okay, this is the motion of the vane, and the jet leaves the outlet at an angle of 90 degree. Okay, now B dash C dash represents the relative velocity VR2. Now we know if the jet enters the plate with a relative velocity VR1, and if the plate is smooth, it will come out with a relative velocity VR2, and we know VR1 is equal to VR2. Now this C dash D dash represents velocity of the plate U2, which is equal to U1, and which is equal to the overall velocity of the plate U, which in this problem is given as 20 meter per second. Okay, now as beta, okay, this angle beta, it will be 90 degree. Why? Because this is 90 degree. Okay, so beta will be 180 degree minus 90 degree, which will be 90 degree. Now if beta is equal to 90 degree, okay, if beta is equal to 90 degree, so we have seen here, if beta is equal to 90 degree, VW2 is equal to, or velocity of whirl is equal to 0, and velocity of flow will be equal to velocity of absolute velocity. So in this case, velocity of flow will be equal to absolute velocity. That means B dash D dash will represent both VF2, that is velocity of flow at outlet, and absolute velocity V2 at the outlet. Okay, and this is the angle phi. Now what is angle phi? It is the angle of vane at the outlet. We also have to find out phi. Okay, now we'll find out each property individually. Now vane angles at inlet and outlet are theta and phi respectively. From triangle BCD we have, okay, we'll see what is triangle BCD. Okay, this is triangle BCD, okay, having angle theta. Okay, now tan theta is from a triangle BCD, tan theta is equal to BD upon CD. Okay, this is theta, so tan theta will be opposite upon adjacent. It will be BD upon CD. Okay, BD upon CD, but we know CD is equal to total AD minus AC. Okay, AD minus AC. Now what is AD? It is velocity of whirl at inlet, VW1, and what is AC? It is U1, or velocity of the plate at inlet. So BD upon CD, where CD is AD minus AC, BD is velocity of flow at inlet, BD represents velocity of flow at inlet, and AD is velocity of whirl, and AC is velocity of plate. Okay, now here velocity of flow will be equal to sine component of absolute velocity. Okay, this is absolute velocity V1, its value is 30 meter per second. Okay, so what is VF1? We know sine alpha, this angle is alpha, sine alpha is equal to opposite upon hypotenuse. Okay, opposite is VF1 upon hypotenuse is V1. So VF1 upon V1 is equal to sine alpha. Therefore VF1 is equal to V1 sine alpha. V1 is 40 meter per second and alpha is 30 degree. So VF1 is 20 meter per second. Okay, similarly VW1 or velocity of whirl. Now here velocity of whirl is the cos component of V1, that is absolute velocity, that is cos alpha is equal to adjacent upon hypotenuse. Adjacent is VW1 and hypotenuse is V1. So VW1 upon V1 is equal to cos alpha, and therefore VW1 is equal to V1 cos alpha, where V1 is equal to 40 meter per second and alpha is 30 degree. So VW1 or velocity of whirl at inlet is 34.64 meter per second. Okay. U1 we know it is given 20 meter per second. Therefore tan theta is equal to BD. What is BD? It is VF1, that is 20 upon AD. What is AD? It is VW1. What is VW1? It is 34.64, and U1 is 20. So if we replace all these values, we get tan theta is equal to 1.366. So theta is equal to tan inverse of 1.366, which will be equal to 53.79 degrees. So we have found out the vane angle at the inlet, that is theta. Its value is 53.79 degree. Next, again from triangle BCD we have sin theta is equal to VF1 upon VR1. Okay, sin theta. Okay, sin theta will be opposite upon hypotenuse. Opposite is VF1 and hypotenuse is VR1. So VF1 upon VR1, or we can say that we will take VR1 here and we will take sin theta at the denominator side. So VR1 is equal to VF1 upon sin theta is equal, VF1 is 20 and sin theta, we know it is 53.79 degrees, we have found it out. Okay, so VR1 is equal to 24.78 meter per second. Okay, now we know from the inlet and outlet velocity triangle that VR1 is equal to VR2. Okay, so we have found out theta. Now we have to find out 5. So we will go to triangle B dash C dash D dash, that is the outlet velocity triangle. This is B dash, C dash and D dash. Okay, now cos phi is equal to U2 upon VR2. Now U2 is equal to U1, which is 20 meter per second, and VR2 is equal to VR1, which is 24.78 meter per second. Okay, so phi is equal to cos inverse of 0.8071. Okay, 0.8071, because 20 upon 24.78 is 0.8071. So cos phi is equal to 0.8071 and phi is equal to cos inverse of 0.8071, which is 36.18 degree. So we have found out theta and phi, that is the vane angles at inlet and outlet respectively. Thank you.